Good morning, one and all. I am Dr. Ramya Swetha, Assistant Professor, Department of Civil Engineering from Institute of Aeronautical Engineering. Today, our topic is physical and chemical modification in another kind of applications. What we are going to understand in this, we will see in this class. So, as per admixtures, we understand in different scenario. Now, we are going to understand in another point of view, lime. What will happen once we choose the lime, and as per the shear strength point of view, the required whatever the shear strength is there, we are going to increase that shear strength in some extent. For that purpose, how much percentage of lime we are choose, that kind of practical application we observe in our previous class. Now here we are going to understand to improve the durability and reduce the permeability of the concrete in a marine environment by adding silica fume admixtures. So in this example, what we understand, what are the step-by-step procedure is involved in this, we are going to see in this class. And few more different examples are also we will consider. And later we will conclude this physical and chemical modification to this class. So we observe so many practical and various problem conditions, how the process we follow, we will see. So now here, to improve the durability, so not compressive strength, shear strength, not like that, it's durability. So it means it should be the more durable. So we are going to improve the durability and reduce the permeability of the concrete in a marine environment by adding a silica foam and admixture. In this environment is also different. So these are the conditions. For this we are going to identify the requirements is the primary step. So in this, the step-by-step procedure, identify the requirement, select the appropriate admixture, mix, design adjustment, mixing, testing. These are all the step-by-step procedure which is involved in this modification by admixture using these modification, physical and chemical modifications techniques. So in this, we are going to identify the requirements is nothing but increase the concrete resistance. Whenever it is durable means we are going to increase the resistance and to chloride ion penetration. So it means the durability is nothing but concrete resistance is going to increase. So in this concrete resistance to chloride ion penetration, in sometimes various different kind chemicals, whether some acids, HCl or like that, or Na2SO4 or MgSO4, magnesium sulfate. So these are the various kind of sulfates and acids, they are going to attack the structures in marine. Not only these, so many various different chemicals, magnesium, not only magnesium sulfate or acids. So they are going to affect the structure because in environment, in marine environment is different. So the attack, and it is the humidity and the flow and how much the waves. These are all the parameters which we are going to include. So according to this, the corrosion will happen, the resistance will get. In coastal regions, we may observe this kind of resistance. The concrete resistance, the corrosion will happen, the corrode and the rust will form. So these kind we observe because of the more humidity is there in those regions. So for this, for getting the durability means we have to increase concrete is going to resistance for these different kinds of chemical attacks. Sometimes acid rains are also affect the structures because of the various chemicals which are going to involve those kind. So because of the environmental changes, these are all the parameters which are going to include in this resistance. So for this attacks and these chemical attacks and what are the various things are going to happen in marine environment, for this we have to understand the concrete resistance is the increase of the concrete resistance is the requirement for getting the durability, better durability. So in this, the thing we have to understand. And also in this, we understand one more point, increase the concrete resistance to chloride ion penetration and also improve overall durability of the concrete is also important. It depends upon the particular as well as where we are going to introduce. Now we are going to select appropriate admixture. This, it may look very simple, but this is the one of the key point to improve the durability under some sort of these marine environmental situations. To improve overall durability and selection of the admixture plays a vital role. So here they are mentioned the silica foam admixture. Otherwise, choosing which type of admixture for this environment, it is very difficult. So as a civil engineer, they'll give the instructions. As a civil engineer, we are going for the give the better durability means they tell here some chemicals are more. So these kind of effect is we are getting this structure. So what are the remedies are there for this? So we will know in generally. That's why I choose this example for adding silica foam is they mentioned. If not mentioned, the choose of the select appropriate admixture plays a very key role in this particular physical and chemical modifications for getting the desired properties that to these kind of scenarios. So in this, choose silica foam due to its ability to significantly reduce the permeability. So already we know silica foam because significantly reduce the permeability. So we know some admixtures how they behave. So according to that, the choose of material is so easy for us. So now move on to the mixed design existment. So existing mixed design, the cement is 350 kg per meter cube, water is 175 kg per meter cube, sand is 700 kg per meter cube, aggregate is 1100 kg per meter cube. In this, cement is 350, sand is 700 and aggregate is equal to 110. In this is equal to 1, this is equal to 2 and this is nearly not exactly 3, somewhat. So we are adding means 10, so some point 3.1 like that. This is the 3.1, like this is the mixed proportion. So we are scaling to the 1 means this is the mixed proportion 1:2, 2:2, almost it's 3. It's not exactly 3, some sort 3.2 it may be according to the calculation we may do. So like this we are going to understanding the existing mixed design. So after that, here we are going to replace the 10% of cement with silica fume. So existing mixed design is, we know it will satisfy all kind of conditions. It will reach the target mean strength. Now replacing 10% of silica fume, that is in 350 kg, 35 kg we are going to use this silica fume. It means 3 in this 350 minus 35, that is nothing but 350. So this 315 kg of cement and 35 kg of silica fume we are going to choose for this adjustment mixed design. We are going to replace. So this is also important term. In some of the situations they may demand add of material. Here we are replace the material. This is also thing we are going to understand. Here we are going to add the material and replace the material. Here we are replacing that too for cement. In some of the cases, they may replace with fine aggregate also. Or it may be sand also. In some of the situations, they may add water. In water also, they are going to add. Or superplasticizers or maybe add to that particular mixed design. It depends upon the what is the practical scenario which is involved. It depends upon the, whenever we are doing this mixed design adjustment, not only for the cement. It may water, it may be sand, it may be aggregate or any superpluses we are going to add or replace. It depends upon the problem statement what we choose in that. So here we are going to replace 10% of cement with silica fume. That is 35 kg of silica fume we are using. Content. In this mixing, thoroughly mix the concrete with the silica fume to ensure uniform distribution. So the mixing, the proper mixing is also important whenever we are replacing the cement with the silica fume, that to 10% of by weight of the cement. So the mixing process, so it completely cement, sand, water, aggregate is different scenario. We are adding some other kind of, we are replacing some other material in this silica fume. The mixing process is uniformly distributed, is we have to ensure for that portion because of getting the desired properties. In this, thoroughly mix the concrete with silica fume to ensure uniform distribution. Now we are conducting the test. So to perform test, ensure the modified properties meet the desired criteria. We know the existing mix design is already meet the desired criteria. So that is target mean strength. For example, I am telling it is depends upon the which kind of properties we require, what kind of requirement is there, it depends upon. So it depends upon generally compressive strength, like that. We are going to those kind of desired criteria. So for compressive strength, whether it is M20 grade, M30 grade, it depends. So we are choose according to that as per the desired. So these perform tests to ensure the modified properties meet the desired criteria. Now perform a chloride ion penetration test. So here we are because of this resistance and corrosion for the durability point of view. The durability point of view, we are going to introduce this ion penetration test because of the increasing the concrete resistance. The chloride ion penetration is requirement which we do. So these are the tests we are going to perform for understanding the and whether it reach the desired properties or not, or any further adjustment is required for this mixed design. For all these we are perform these tests, that is ensure the modified properties meet the desired criteria or not, and also we are perform the chloride ion penetration test also for increasing the concrete resistance. These are the parameters which we are going to consider in this example. So in this reduce permeability. So these are the steps which are going to involve. We are going to understand. Once they meet these criteria, we are going to follow the procedures. Otherwise, again we are going to adjustment is going to happen. Now, practical example. So reduce permeability and increase durability is required under 10% weight of cement. Original cement is 350 kg per meter cube. Silica fume is equal to 35 kg per meter cube. New cement content is 315 kg per meter cube. Mix 315 kg of cement, 35 kg of silica fume, 75 kg of water, 700 kg of sand and 1100 kg of aggregate. Test this permeability and durability. This we understand. Now move on to the shotcreting technology. Shotcreting a 5 meter high retaining wall for slope stabilization. For 5 meter high retaining wall. Slope stabilization. Shotcreting. So shotcreting is the technology. Slope stabilization is the outcome. We are following this process for getting the slope stabilization under 5 meter high retaining wall. Here we are going to do the surface preparation, clear the surface to remove loose materials and containments. Nozzle setup, set up the shotcreting nozzle and equipment. The mix preparation. In this mix design, cement is 400 kg per meter cube, sand is 600 kg per meter cube, water is equal to 160 kg per meter cube. In this, the cement and sand ratio is 1:4. We understand the proportion between the cement and fine aggregate, that is nothing but the sand, is 1:4. So now here we are at 2% of accelerated by weight. So that is nothing but the 2% of acceleration by weight of cement, that is equal to, the weight of cement is equal to 400 multiplied by 2 by 100 percentage. 2% it means 2 by 100, that is equal to 8 kg. So 2% of accelerated we are going to add to the cement. Here we are adding the 8 kg to the cement. We are not going to replace. We are adding to these 8 kgs to the cement as a accelerated. Now in this we are going to apply the mix using high velocity through the nozzle to the prepared surface. That application rate is 1 meter cube per hour. So we are applying this mix using high velocity through the nozzle and also to prepare the surface. Here that application rate is 1 meter cube per hour. After that, cure the applied layer to ensure proper hydration and strength development. These are the steps which are going to involved in our shotcreting technology. In this, the practical application requirement: shotcrete a retaining wall, that is cement 400 kg, sand 600 kg, water 160 kg, accelerated 8 kg. Thus application rate is 1 meter cube per second. It involves the procedure: clean the wall surface, set up the shotcreting equipment. We follow the procedure for shotcreting: prepare the mix and add 8 kg of accelerator. We are going to prepare the mix and we are add. So that is the difference between adding and the replacing. Already we previously discussed in this class, in previous slides. So apply the mix at a pressure of 100 psi. Cure the applied layer for 7 days. This is the procedure which we follow for the shotcreting of a retaining wall. So in this, modification at the depth by grouting. So the step-by-step procedure is drilling holes at the required depth, that is 10 meters and 2 meters apart. Here, stabilize the loose soil at the depth of 10 meters for the foundation support. So in this 10 meters for foundation support, for stabilizing the loose soil. So using this depth by grouting is the technique. Depth by grouting is the technique. So desired properties are soil stabilization and foundation support. For foundation support construction element for foundation. So in this, drilling holes at the required depth and spacing 10 meters depth and 2 meters apart. Grout mix proportion: the cement is equal to kg per meter cube. Water and other things we are going to understand in this grout mix proportion. Inject the grout under pressure into the drilled holes, that is pressure bar 3 bar. Monitor the grout flow and pressure, ensure the uniform distribution. Allow the grout to cure and gain strength within the 25 days. These are the various parameters which we are going to involve on this. In this practical example, so objective: stabilize soil for foundation support is the practical example. The grout mix, cement and other water and remaining, we follow the procedure: drill holes 10 meters deep and 2 meters apart. Inject grout at 3 bar pressure. Monitor until the grout refusal. Allow curing for 28 days. And also move on to the crack grouting. For practical application, repairing a 5 mm wide and 2 meter long crack in concrete slab. So in concrete slab, the crack length is 2 meters, its wide is 5 mm. In this, first we are identify the crack and mark the cracks to be grouted. The next step, we are going to surface cleaning. We are going to clean the crack surface. And grout mix proportion, we choose which type of mix proportion is suitable for this concrete slab. For that is epoxy resin. So that mix proportion is equal to 2:1. In this, inject the grout into the cracks under lower pressure, that is equal to pressure 0.5 bar. Allow the grout to cure and bond with the crack surfaces within the 24 hours. These are the parameters which we are going to understand. In this practical example, repair a crack in concrete slab. So this is the objective where the crack dimensions are 5 mm wide, 2 meters long are the crack dimensions. Now grout mix epoxy resin 2:1 ratio. Clean the crack, prepare the epoxy resin mix and inject the epoxy into the crack using lower pressure. Allow the curing for 24 hours. These are the various kinds of applications we are going to conduct. And one more is the compaction grouting. So in different way, improve the bearing capacity of soil for a new building foundation. So in this, the step-by-step procedure, the drill inject point to be desired depth is 10 meters. Here the design depth is 10 meters. The grout mix proportion, sand is 600, cement 300, water 150. It means cement and fine aggregate, that is nothing but the cement and sand mix proportion ratio is 1:2, 300 and 600. So within the 1:2 ratio, we are prepare the grout mix. That mix we are going to inject the grout at lower pressure 1 bar to displace and compact the surrounding soil. Now monitor the injection pressure and volume. So we are monitoring the injection pressure and the volume, whether the desired, we reach the desired property or not, or required property or not for bearing capacity point of view for a new building. This depends upon the which type of the problem statement. So in this, increase the bearing capacity, we choose the drill holes for 10 meter depth and inject and monitor until desired compaction is achieved. So the desired compaction is achieved, that monitoring and quality control is very, very important for longevity of the structure, and also the getting the desired properties achieved or not, or any modifications are required for this at any stage, whether it is mixed proportion, whenever we are doing. So this is important step, that monitoring gives the desired properties for achieving the desired properties. These are the various steps which are going to involved in this particular chapter. We understand in this module various kinds of modifications we are going to consider in even the same technique, in this compaction grouting and crack grouting and whatever the different types of techniques, admixtures, for various practical problems we are understanding. The procedure is maybe same. The procedure is same. The step-by-step procedure is same. But what we choose, how we are going to implement, how to monitor, what are the various properties we are going to address. In some situations, we are cracking point of view. Same technique we may use for bearing capacity and also the increasing the shear strength, like that. So the properties, how we are defined as per the problem statement, we are defining the properties for the particular technique. So in some cases, same technique may use for the different properties. It depends upon the problem statement and what we get, what are the project requirements. These are all we are going to understand in this particular module in practical session, practical problems, what we are going to see in generally, and also how we solve the problems using numerical examples also in this particular unit. This is for this problem solving session we are going to conclude for module 4, that is physical and chemical modifications. In this aspect, we are going to understand various problem statements and practically where the soil properties are going to increase or modifications is required. We understand in this module. We will see next module. So in our next class, we will discuss what are the problems involved, what are the practical issues we are going to understand in other module. We will see in our next class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.